So today we will be talking about congruency of triangles. So you may know that there are three main rules for proving congruency. You have SSS, ASA, and SAS, right? So if you can show three corresponding sides of any two triangles are equal, then the two triangles must be equal. Now, when we talk about ASA, the order does not matter. So ASA works to prove congruency, but AAS also works if you want to prove congruency. So the order isn't strictly important. But in SAS, the order is very important, right? You have to go in the order of side, angle, side, equals, side, angle, side. Otherwise, it will not work. So SSA does not work, but SAA does work. Now, why this is the case is a topic for another video, but there is one case in which SSA works, and that is if the angles that are equal, so let's assume A and P are equal, and they are the largest angles of the triangle. So if angle A is the largest angle of triangle ABC, angle P is the largest angle of triangle PQR, and A equals P, and we have any two sides that are equal. So let's say side C equals side R and side A equals side B. So I have SSA equals SSA. Then these triangles must be congruent. So we'll write this down. We want to prove that triangle ABC is congruent to triangle PQR if we are given angle A equals angle P, and they are the largest angles, and if two other sides are equal. So let's assume C equals R and A equals P. I can't have C equals R and B equals Q, otherwise that's just SAS, and I already know that works. So I must have A equals B, and either C equals R or B equals Q, it doesn't matter, the proof doesn't change. So without loss of generality, I'll assume that this is what I'm given, right? The largest angles are equal, and two other sides are also equal. And using this information only, I can prove that the triangles are congruent. So how can I do that? Let's think about it. If I'm proving congruency, there are 6 things that I can prove to be equal, right? So I have 3 sets of angles and 3 sets of side lengths. And by the way, capital letters mean angles, lowercase letters mean side lengths. So I'll use blue, I guess, to make the distinction. And I can have P equals A, Q equals B, R equals C. Now I'm already given this is equal, and I'm given this is equal, and this is also equal, right? So if I can prove that angle C equals angle R, then by AAS, right? AAS, triangle ABC must be equal to triangle PQR, right? So if angle C equals angle R, then the two triangles are congruent, and that concludes my proof. Or I could show that side Q equals side B, that these are equal. That could also work. In this proof, I am going to be using this method. I'll show that these two angles are equal. So by AAS, triangle ABC must be congruent to triangle PQR. And I'm going to prove this again only using this information, nothing else, right? So let's get started with the proof. Okay. So we'll start with triangle ABC. I'm going to use the sine law on triangle ABC, which means side A over sine A, not B, over sine A equals B over sine B, and that equals C over sine C, right? That's just the sine law. And I can do the same thing for triangle PQR. So P over sine P, and this is the same thing again. Okay, so I have this is just the sine law. But I'm given side A, so I'll write this down here. I'm given this, and I'm given angle A equals angle P, so a sine A must equal sine of P. If this is equation 1 and this is equation 2, then by dividing 1 and 2, I have A equals P sine A and sine P. So I'm using the information I'm given to deduce that A over sine A equals P over sine P. But I have that written down here. So I can put an equal to sign between all 6 of these, and I have this massive equality, right? Because A over sine A equals P over sine P, then A over sine A must equal Q by sine Q equals R by sine R, and the same thing for B and C, it's all equal. So I have this massive equation. So I want to work with C and R, so I'm going to pick this and this, and we'll work from there. So let's free up some space. Okay. So I had C over sine C equals R over sine R. But I'm given C equals R, which means I can cancel both of these, and that gives me sine C equals sine R. This could mean one of two things. Either angle C equals angle R, which is what we want, or C equals 180 minus R degrees, right? In either case, sine C would equal sine R. But this possibility here is nonsense. This is not possible. Why is that the case? Well, let's assume we're going to use a proof by contradiction here. We'll assume C equals 180 minus R. if this were the case, then I could use the angle sum property in triangle ABC. So I have A plus B plus C equals 180. I will rewrite A as P because A equals P. I can do that. I'll use this over here. C equals 180 minus R, and I'll write B as it is. And this equals 180, right? So I just rewrote A as P and C as 180 minus R. I can cancel this and bring R to the other side. So I get R equals P plus B. But what does this mean? This means that R must be greater than P. B is not negative, it's a positive value. P is also a positive value. These are all angles of a triangle. This implies that P is less than R. But I have P is the largest angle, right? P cannot be less than R because it's the largest angle. This contradicts what I initially had. So by contradiction, our assumption must have been wrong. So this possibility cannot be true. So the only possibility is that angle C equals angle R, and therefore by AAS congruency criteria, triangles ABC and PQR must be congruent, which concludes the proof. And yeah, I'll write that down. Triangle ABC is congruent to triangle PQR, which is what we wanted. QE. Yeah, that's about it.